The American engineering geniuses came together to design roads that should be physically impossible, and the way they pulled it off will shock you. Only geniuses were able to pull off the construction of this mountainside road because the terrain alone where it was built presents a direct confrontation with gravity, altitude, and instability. In the majestic Andes Mountains of South America, engineers were tasked with splitting sheer cliffs to build massive roads under conditions so extreme that even the smallest mistake could send the entire project sliding into ravines hundreds of meters deep. Yet through millimeter-level calculations, precisely controlled drilling and blasting, and heavy machines weighing hundreds of tons operating while clinging to steep mountain slopes, engineers managed to create winding roads that trace the mountainsides like steel threads, reconnecting regions that had been isolated for centuries. Across Peru, Chile, and Bolivia, building roads in the Andes is not just a transportation challenge, but a constant struggle against some of the harshest terrain on the planet. Many highways are constructed at elevations between 3,000 and 4,500 meters, where thin air can reduce labor efficiency by as much as 30 to 40%. Weather conditions can shift rapidly, moving from intense sunlight to snowfall within hours. In these projects, more than 6% of total construction costs are spent not on the road surface itself, but on rock excavation, slope stabilization, and landslide prevention, reflecting the extreme risks involved. Mountain roads in the Andes are usually built in two primary stages. The first stage follows the outer cliff face, where engineers cut the road directly into the mountain, stabilize the slope using anchors and retaining structures, and install protective systems to shield the roadway from falling rocks. When the terrain becomes too steep or unstable, construction shifts to the second stage, tunneling through the mountain to bypass the most dangerous sections while reducing exposure to landslides and extreme weather. The construction process begins with the mountainside still completely untouched. Engineers precisely determine the road center line and mark construction boundaries directly on the rock face. Drill holes are laid out according to detailed calculations, and explosives are loaded in carefully controlled amounts to break the rock in sections without compromising the mountain's overall stability. After each blast, excavators move in to remove loosened rock and soil, gradually clearing the construction surface. The debris is loaded onto heavy-duty trucks positioned along temporary access roads and transported to designated disposal areas planned in advance. In certain locations where the terrain allows, bulldozers push material directly down into rivers or steep slopes below, significantly reducing clearance time. Bulldozers then shape the road by pushing away excess material and carving the mountainside into the initial roadbed form. Operators constantly adjust the blade to achieve the required slope and elevation, creating a rough but stable surface for further work. This cycle of drilling, blasting, excavating, bulldozing, and grading repeats section by section until a continuous roadway takes shape, firmly anchored to the steep cliff face. Once the ground is leveled and stabilized, trucks deliver graded aggregate or crushed stone in strips along the route. Wheel loaders spread the material evenly, while motor graders shape it into uniform layers with precise elevations. Water trucks control dust and add moisture, allowing rollers to compact each layer through repeated overlapping passes. In tight sections near the cliff face, workers use hand compactors to prevent uneven settling. To secure the surrounding rock, workers strap into safety harnesses and climb the steep cliff. Using pneumatic drills, they remove unstable rock piece by piece, constantly checking cohesion to prevent sudden failures. All personnel wear full protective gear. Afterward, steel mesh is fixed across the cliff face to hold loose fragments and reduce rockfall risk. With the roadbed complete, asphalt paving begins. A bonding coat is sprayed and heated, followed by hot asphalt laid by a slow-moving paver. Crews correct edges by hand as rollers compact the surface. Once cleaned and cooled, the road forms smooth curves along the mountainside. In near vertical sections, reinforced concrete columns and prefabricated road modules are anchored into bedrock, allowing the roadway to extend across otherwise unreachable terrain. When cliff carving or suspended roads are impossible, engineers build tunnels. Ventilation shafts are drilled first using raise boring to supply fresh air and remove exhaust. Tunnel boring machines are then assembled underground with laser precision. Once active, the machine crushes rock, removes debris by conveyor, and advances in repeated cycles until completion, followed by strict inspections to confirm safety and structural integrity.